This video is going to go over the real number system, and there are tons of videos and graphics for these. I just chose one here, but you're more than welcome to go on Google and you can type in the real number system and look at the images, and there'll be lots of nice colorful pictures. You can also go to YouTube, and this is one, I don't always say go to YouTube and just type in things. This is one time would be completely all right to do that, because the real number system is pretty much the same no matter what type of math class you would be going into. So throughout the semester, we've looked at different types of numbers, and this is going to kind of wrap it all up for us. So I'm going to start way back at the very beginning of the semester when we started in chapters 1 and 2. We started with the natural numbers. So the natural numbers. So the natural numbers are the ones that are 1, and we keep counting to infinity. No decimals, no zeros, no negatives. This is what we say you're naturally born to learning when you count, like what babies learn to count with. They're also called the counting numbers because of that. Then we went to chapter 3. That was the one with the different bases and also different ways to add, subtract, multiply, and divide. And we added the whole numbers. The whole numbers are all the natural numbers and then also 0. So all natural numbers are whole numbers. 3 is a natural number and a whole number. 27 is a natural number and a whole number. So all natural numbers are whole numbers. Remember those little ellipses, the dot, 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 says it goes on forever. So big numbers like thousands and millions are also in those lists. We're just lazy and didn't want to write them out. Then for exam 2, I introduced integers. Integers include all those whole numbers and their inverses. So this is where we got the negatives. So all the whole numbers plus their inverses. So those are negatives as well. No decimals, no fractions yet, are numbers that couldn't be reduced down into natural numbers. Every natural number is a whole number and an integer. So 27 is a natural number, a whole number, and an integer. It's not true going down. -3 is only an integer. It is not a whole number and it's not a natural number. Then in chapter 6, I introduced rational numbers. I'm not going to be able to list those out in a nice little pattern. There is a way to do that. It's really cool. It's like a pinwheel, but it takes up a whole page, so I'm not going to go through all of that. The rational numbers are things that we can write in fractions. So maybe like 1/2. We also can have negatives. You can have mixed numbers. You can have improper fractions. You have decimals that stop, so terminating. And you have decimals with repeating patterns. So the ones that use those like repeatins on there. Those are all the rational numbers. And that takes us through everything we've seen so far. We did the repeating things. We've done percents. So we haven't looked at the other side of this, numbers that don't fall into this category. Every number we've seen so far has been a rational number. Because remember, down here, the natural numbers are rational numbers. I could write 3 as a fraction. I could write it as 30/10 or 3/1. So everything I've seen so far could be written as a fraction. Now we're going to introduce a new type of number called irrational numbers. And irrational numbers literally mean not rational. So ir means not. So these are the numbers that are not rational. I cannot make a whole list of those. That's a whole nother topic. It's really cool, but that's another topic that we're not going to go over. We have a very famous irrational number, pi. These are numbers that have symbols that go with them. If you've taken classes that use the E, like in the PERT formula, you might have had that one. We also have square roots. These are square roots that can't reduce down. So it wouldn't be like the square root of 25 because that's 5. But square roots that we cannot reduce down. And we're going to get to spend a lot more time in these square roots in this section. You also have decimals that do not terminate. because both pi and the square root of 2, their decimals don't stop. Our calculator stops after 10 or 12 decimal places, but the rest of the decimals, like, they keep on going. Our calculator just doesn't show us. They're there. So I'm just going to make one up. So these are decimals that don't stop. So this is their decimal form. They have to have this ellipse down here on the end. And then you have a really kind of, I think it's a neat one. This is a decimal that doesn't stop and doesn't have a pattern. I should have added that up there. These decimals don't stop and they don't have a pattern. Over here, these decimals didn't stop, but they had a pattern. We could have used it or repeated. The irrational numbers, the decimals don't stop, but there's no pattern. I don't know what's going to happen next. That's what makes pi so neat. There's no two numbers that are always side by side in pi. We cannot write them with that repeating bar that we saw in our other chapters. We cannot do that. Irrational numbers, there's no way to write them as a fraction. So there's no pattern there. So we've got that first one made up. The second one's kind of neat. It looks like, I know what's going to come next, but I can't use a repeating. Because, like, if I just use the number 21 over and over again, there's all these other ones in there that are in the way. So technically this one, I can't use a repeating, so it is an irrational number. If you could use a repeating, that line that we already practiced, then the decimal is rational. If we could not, then it is that irrational number. And any decimal that stops, even if it's 3.14, is rational. Because pi technically is not 3.14. It is a number that goes on and on and on forever. We're lazy, so we say 3.14. But pi is millions and millions and millions and millions of digits long. 3.14 is just 2 digits long, so it is rational. And together, these all make up the real numbers. We are only dealing with the real number system in our class. We're not going to be dealing with the complex plane or imaginary numbers. So every number that we go over is real. Numbers are going to fall into two camps. They're either going to be on the rational side or the irrational. You cannot be in both. You are one or the other, not in both of these guys.